Put in the work now, using what we learned yesterday and applying it to our statements and reasons proofs. Today only, you're going to prove two triangles similar. Real quickly, I need 3 people. 3 different methods yesterday. We showed the proof triangle similar. 3 different methods. 12, 3 different methods. First method. Angle. Angle. Let's keep it rolling. Next method. 1, don't have one, get off. 12. Side angle side. Similarity. And the third method we discussed was 25. Good talk. I'll get back to you. 2. Side, side, side similarity. Now I have a question for you. What do you have to know about these sides and side angle side? And what do you have to know about these 3 sides and side, side, side? They have to be same ratio. So I need to be given actual side lengths. Everyone agree? How many times in a proof this year have you seen a diagram that's got actual side lengths on it? Let me tell you, none. Meaning, what am I trying to tell you? Which method probably are we always going to use in a proof? Angle, angle. Okay, that's probably the only way we're going to solve a proof is by using angle, angle. So, hey, find 2 pairs of angles, we're done. That's it here. Find 2 pairs of angles, we're done. All right, so I have WR parallel to VB. Prove to me first those 2 triangles are similar. And we already went over, main method's going to be angle, angle. So I'm going to ask a couple people, can you find me a pair of angles that are congruent? Back yourself up. 16.
Since the lines are parallel,
They are.
WRS and VS is alternate interior.
All right, there we go. So I have angle R congruent to angle V. Anybody remember what I wrote in the reasons? It's been a couple units. Good midterm review. What's up, Jonah? Stop. Parallel lines imply alternate interior angles congruent. Ha! Perfect. Need another pair. Need another pair for angle, angle. 16.
Angle WSR and VSB are congruent.
Because?
Vertical angles.
Got the verts here. You could have also put what? W and B, right? In the same statement because they're alternate interior. But hey, whatever gets the job done. That's an embarrassing 3. We'll erase that. Please don't call it angle S congruent to angle S. You're better than that. Angle WSR congruent to VSB. Vertical angles are congruent. And now, do I have 2 pairs of angles? Got it. So now you can tell me triangle WSR similar to BSV by angle, angle. Come on now, look at your papers. How many put the congruent symbol? Anybody? Liars. All right, part B. Now I'm going to give you actual lengths. Now we know the triangles are similar. SB 10, WS 15, SV 20, RS, I don't know. You already have a similar statement. You know which sides correspond to each other. And since the triangles are similar, what do I know about corresponding sides? If the triangles are similar, what do you know about corresponding sides? Not congruent, but in the same ratio or proportion. Here we go. So I'm going to look for someone to set up a correct proportion for me here in part B. Could be different ones for different people. Here we go. How about a little help from 13?
You can do 15 over 10 is equal to x over 20.
All right, there's one way. That's a good proportion. And when you get it there, let me know. All right, no big deal. All right. One more. I don't have to spend all day on these proofs. You got to find two pairs of angles to make the triangle similar. So I'll give you a second, look it over, highlight, mark, whatever you need to mark. Rectangle, ABCD. Notice where the two similar triangles are that we're trying to prove. BAD. All right, help me prove those two triangles similar. Need two pairs of angles from you, two pairs. It's a rectangle. I got a perpendicular line. Any angles you see now that I could possibly use here to show they're congruent? How about 21 in the house? Everyone see they both share EBA. EBA is a reflexive angle. Perfect. One pair of angles. Nice job, everybody. How about where's the other pair located? A little help. 17. All right, here we go. What haven't I used in the givens yet? The right. What about them? Where? Okay, where's the right angle in one of the triangles then? Or specifically, because there's a lot of E's, I could put a right angle. Can you name it with three letters? Name the angle that's a right angle. DEQ. This one right here? Okay. Is that in any of the triangles, though? Can you get me a right angle in one of the triangles?
Well, that's going to be congruent to AEB.
Okay, so AEB, though, is a right angle, right?
Yeah.
Okay, so I got a right angle in my green one here. How about the big triangle? Where would there be a right angle in the big one then? Remember, what type of figure is the big one here? What's it tell me in the givens? What type of rectangle? What do you know about rectangles?
They're all right.
Okay, so specifically, where's there a right angle in my yellow triangle up here? There we go. And what do you know about two right angles, Ella? Okay. But before I say they're congruent, what do you have to tell me? That they're right angles. And they're right angles for two different reasons. All right, so I'm not going to put that they're both right angles in the same statement because they have two different reasons. So let me start with AEB is a right angle. So AEB is a right angle. Why is that one right here a right angle? AEB is a right angle because, what do we got? Don't have one. You guys are off your game. 8. So perpendicular lines do what there, Ethan? There you go. And then why is angle DAB a right angle? Different reason. DAB a right angle, why? 24, why? Rectangle implies all right angles, yep. And now just tell me they're what in step 5? Congruent. Got to tell me they're congruent. Can't just leave them right angles. So angle AEB, congruent to DAB, right angles are congruent. And now you got two similar triangles. All right. All good before we go into some hardcore algebra. All good? Yep, let's do it. Little new theorem I'm going to show you called the Side-Splitter Theorem. I'm hoping this helps you set up your proportions a little easier. Okay, this may help set up your proportions slightly easier. So here's what the side-splitter says. If you have a line that's parallel to one side of a triangle, it divides those sides proportionally. Take a look at my example. BD parallel to AE. Let's mark it. BD parallel to AE. So I have a line in a triangle that's parallel to another side of the triangle. Okay? It splits the sides proportionally. Ready? Meaning CB over BA. Everyone see here? CB over BA equals, what do you think on the other side? Splits the two sides proportionally. What do I have on the other side? CD over DE. But the lines have to be parallel. All right? That's what the side-splitter theorem says. Is if I have a line parallel to a side of a triangle, splits the two sides in proportion. All right? Side-splitter theorem. Side-splitter. You'll see why I'm purposely saying that in a second. All right, real quickly, finding y. I have two parallel lines, right? Splits the sides proportionally. How can I use side-splitter now to solve for y? 19 again. Go ahead. 4 over equals. That's using side-splitter. So what do we have? 6y equals 36. What do you have there, Maya? Y is 6. Now, all right, everyone stop. Pencils down here. Pencils down. Do you always need to use side-splitter? The answer is no. I could have given you guys this problem yesterday and you could have done it. Not knowing side-splitter. Because anybody know what you know about these two triangles? They share an angle, right? And they have corresponding angles congruent. What do I know about these two triangles? Similar. So I could have set up a proportion. Ready? 4 corresponds to what in the large triangle? 10. And the y corresponds to, how do we write this side yesterday? Not 9y, but y plus 9. So you can get away without using side-splitter. Okay, I just think it's very convenient and quick for you to use. That's why I'm showing it to you guys. Okay, so either way would have worked here. Either way. All good? All right, let's get hardcore now, I think. Find DB, AEX, AD1, DB is x, and EC is x plus 2. And we are told that DE and BC are parallel. Do you see side-splitter now? Okay, I have two lines parallel, cuts the other two sides of the triangle proportionally. You don't need to use side-splitter, but I think it's just convenient. We know the triangles are similar. Can you set up a nice proportion here for me? Here we go, 14. Okay, you can start that way. That's fine. X plus 2 over x equals x over 1. Some of you guys may have had these flipped. That's fine. We're still cross-multiplying the same things. Thanks, Nate. Everyone ready? Okay, here we go. Cross-multiply. I told you it was coming back, and I can't spend time reviewing it. You get x squared, right? And what do we get on the other side? X plus 2. What's the highest exponent? 2. How many answers are we going to get at the end? 2. Can't get any answers until one side, though, is equal to 0. This is why we spent all of Monday on this. Excuse me, Friday. Move everything over. X squared minus x minus 2. And I don't know what you want to do. If you want to try to factor, factor. If you want to use quadratic formula, use quadratic formula. What am I going to do in here, though, in an honors class? You're darn right. If I can factor it, I'm going to factor. How can I check if it's factorable? Maybe some of you already know if it is or not. But if you don't know if it is, what can I do? Discriminant. All right, I'll do that real quick here. B squared minus 4AC. Going to use my store button. Okay, A equals 1, B equals -1, and C equals -2. If you plug in those values, what do we end up getting for the discriminant? Anybody find it? I'm not going to slow down here. B squared minus 4AC. 9. Is 9 a perfect square? So what can I do here? If 9's a perfect square, is this factorable? So I'm going to factor it. If you want to use quadratic formula, hey, I don't care. I don't care. I'm not going to think any less of you at all. All right, if you want to use quadratic formula, go right ahead. All right, but in an honors class here now, we're going to factor. X and X, 2 and 1. What do the signs have to be to add to a negative 1? What do my signs have to be? Negative 2 and positive 1. So one answer I get is X equals negative 1, and the other is X equals 2. I'll wait till somebody says something. Yep. X is, hey, look, you got a diagram. Here's X, and can this be negative 1? No. All right, so I need to reject that. But again, am I rejecting it because the answer came out to be negative 1? No, why am I going to reject it? This came out, the side length came out to be negative 1. Okay, cannot have a side length of negative 1. There we go. So it just ended up, we got to find, hold on, find dB. dB was X, okay, just making sure. 2. Questions? All right, we're going quick here now. I'm not worried about the factoring quadratic formula anymore. All right, last one, ED. Find ED. Let's see, DE parallel to BC. AD is 6, DB X minus 1. ED is X, CB 6. Okay, whoa. I do this one last on purpose. What's the name of the theorem I showed you today? Here we go, everybody. What's the name of that theorem? One more time. What's the name of that theorem? Side-Splitter. It is not base splitter. Does everyone see? I cannot apply that theorem here. I need, if X and 6, ready? Whoop, we're right over here. I move the X here and the 6 here. Sure. But do you see I cannot use side splitter here? Are we all good there? But can I still set up a proportion? Darn right I can. Let's go. Give me a side in, here we go. Give me a side in the smaller triangle. 11, give me a side in the smaller triangle. 6, oh, I like it. Went hardcore right away. What would the 6 correspond with in triangle ABC? How long is AB? Because that's what I'm going to put there. How long is AB? Come on, be there for me. Be there. 5. X plus 5. Everyone see where we got it? X plus 5. X, and then combining the 6 and negative 1. Do we see? Stop. Do we? That's the hardest part of this problem. Everyone see why it's X plus 5? All good? All right. And then X, I don't need to ask you this, corresponds with 6. Cross them up for me. Here we go. Cross multiply. What are you getting? 15. Here we go. What do we get when we cross multiply?
X squared plus 5x plus 36.
Hey, 2 answers, right? 2 answers. 2 answers. Get everything equal to 0. It's your choice tonight. Your choice. Quadratic formula or factor it. I will let you know this is factorable, so we are going to factor it. But you guys go ahead, use quadratic formula if you need it. It is factorable. 2 numbers that multiply to 36 but are 5 apart. Dun, dun, dun. 9 and 4. Plus 9 minus 4. So you should get out x equals -9 and x equals 4. All right, well, hold on. Let's go back and check. Don't I have a side x? So which answer is not going to cut it? -9. And what were we finding here? Find ED, which was we labeled x, so 4. Oh, no, let's calm down. If you are using quadratic formula, you should still get -9 and 4. Okay, if you need, seriously, if you need a little help on how you got -9 and 4 using quadratic formula, let me know. Okay, let me know. Questions at all? Yes, Skylar.
How do you know where the base is in that triangle?
How do I know where the, well, okay, remember the parallel lines split the two sides they're connected proportionally. Okay, so since this was the parallel line, it splits these two sides proportionally. That's how I knew I couldn't use side splitter here.
Look, I understand why we can't use side splitter, just in general, how do you know where the base is?
I probably shouldn't have used the word base. All right, because the only thing you can tell where a base is an isosceles triangle. And that's the non-congruent side. Okay, so I probably misspoke. I shouldn't have said base here, but use it. Do you see why I can't use side splitter? Because it would need to split AC and AB. Okay, so I probably shouldn't have said base because isosceles triangle is the only type of triangle you can really tell me where a base is. Okay, other questions? Okay, don't pack up early. Get rolling. Don't pack up early.